Good morning everyone. So as you know, in the previous class we discussed about the application of the bisection, and in the last of the class I discussed this application also, and I said that I will discuss in our next class, right? And for this one I explained that, how to take the limits, right? If they are not given the interval, then how we have to. So simply here I took that the value x value as 0, 1, 2, 3 and so on, and for 2 we have a negative value and for 3 we have a positive value. Okay, now here again I am going to start this application, so please be careful with this one, because if you understand this method then it is easy. Okay, now f of 2, that is 8 minus 2 2s are 4 minus 5. Now 8 minus 9, which is equal to minus 1 less than 0. Now f of 3. F of 3 means 3 cube, 27 minus 3 into 2, 6 minus 5. Now 27 minus 11. Then what we get? 16, which is a positive. So for 2 we have that it is a negative, and for this 3 we have, for 2 we have a negative and for 3 we have a positive. Done. So now this is nothing but the function value, and now here what I have to do? I have to calculate the value of the x naught. So what will be the x naught value? X naught is nothing but 2 plus 3 by 2. Now it is 5 by 2. 5 by 2 means simply it is nothing but 2.5. Okay. So now here what do we have to do? We have to go for iteration number 1. So in this iteration, first of all we have to calculate f of x naught. That means 2.5 whole cube minus 2 into 2.5 minus 5. So now here, of course here we have to take the help of the calci. So now here 2.5 whole cube, directly I am calculating 2.5 whole cube. It is 15.625 minus, and 2.5 into 2 means 5, and next minus 5. Now here 15.625 minus 10. Now obviously we will get it is nothing but 5.625. Is it a positive or a negative? Positive value. So which is a greater than 0. So therefore f of x naught is positive. So if it is a positive, then what do we have to say? We have to say that the root lies between. So here where the root lies, and for this 2 we have a negative sign, so and for this one, for the new value positive now, so that's why we have to take 2 comma 2.5. Next what we have to calculate? x1. So x1 means 2 plus 2.5 by 2. So now here 2 plus 2.5 means 4.5 divided by 2. Now it is 2.25. Therefore x1 equal to 2.25. Box it. Now compare this x1 with x0. x0 is 2.5. Of course 2 is same, but after the point we have a different value, right? So that's why here again we have to go for next iteration. Now f of x1. f of x1 means 2.25 whole cube minus 2 into 2.25 minus 5. Now 2.25 whole cube, that is 11.39. Actually here we have that 390625. I am taking 39 up to 39 only, because after this one we have a 0. Now minus what I have, 2 into 2.25. Then what we get? 4.5 minus 5. So now here the value 11.39 minus 4.5 minus 5. Directly in the calci we have to. So now it is nothing but 1.89. Okay. So 1.89 means it is a positive or a negative? Again it is a positive value. So therefore f of x1 is positive. So therefore what we have to say? The root lies between. So where the root lies? Root lies between. We have to take one negative value, one positive value. It is a positive, no? So now negative value is 2 and positive value is 2.25. Clear? So now the new interval is nothing but 2 comma 2.25. Next, what we have to do? We have to calculate x2. So x2 means 2 plus 2.25 by 2. So now take the addition, 2 plus 2.25, which is equal to 4.25 divided by 2. Directly I am taking. Now it is 2.125. Now therefore x2 is equal to 2.125. If you observe this x1, we have the 2.25, and here what I have 2.125. Of course it is near to this one but not exact. That's why we have to go for next iteration number, iteration 3. So in this iteration, f of x3 we have to calculate, f of x2 we have to calculate. That means 2.125 whole cube minus 2 into 2.125 minus 5. So again same thing, 2.125 whole cube. Then we have that 9.59570. So I am taking up to 4 digits, 57 minus, next what we have, 2 into 2.125. Now it is 4.25 minus 5. Now then what we get, 9.5957 minus 4.25 minus 5. So then what we get, 0.3457. Again we have that it is a positive only, right? So now that's why here what we have to take, we have to take that it is a positive value. Therefore we have to write that f of x2 is again a positive number. Therefore what we have to say, the root lies between 2, 2.125. So see, if you observe this interval 2 and 2.1, very near interval, but again in that interval, like for example if you take the measuring scale, in that we can see that 1, 2, 3, 4 and so on in centimeters we will get, and between 1 and 2 we will get the 10 lines, right? So that is 1.1, 1.2 and so on. So now here the interval is nothing but 2 and 2.125, right? Which is a very small interval, and in this interval we have to find the root. Now what is the x3 value? Now x3 we have to find, that is 2 plus 2.125 by 2. Okay, so now 2 plus 2.125, it is 4.125 divided by 2, 2.0625, and here therefore x3 is equal to 2.0625. Now we have to observe x2. What is x2? 2.125, but here what I have, 2.0625. So again we have to go for the next iteration. Now iteration number 4. Now f of x3 equal to 2.0625 whole cube minus 2 into 2.0625 minus 5. Now what we get here, whole cube, 8.773681. So now here I am taking that 77736. After that I have 8, so I am taking that 7 minus 2 into 2.0625. Now it is again 4.125 minus 5. Okay, so now here 8.7737 minus 4.125 minus 5. So it is minus 0.3513. Now we have the value of the f of x3 as a negative. So now what I have to mention, f of x3 is negative. Therefore the root lies between. So where the root lies, now we have to ignore this 2. That means the new value is 2.0625 comma 2.125 is the new interval. Now what we have to calculate, x4. Now what will be the value of the x4? 2.0625 plus 2.125 by 2. Now I am taking that the addition of these two, 0625 plus 2.125 divided by 2. Now it is equal to 2.09375. So here finally we have that x4 is equal to 2.09375 I have. So I am taking that it is nothing but 94. And now if you observe this x3 and x4, so x3 is 2.0625 and here I have that 2.094. Okay, it is somewhat near. So that's why I am going for, of course here only one digit is same but second digit is not same. That's why here we have to go for the next value, next iteration. Now iteration number 5. Now f of x4 equal to 2.094 whole cube minus 2 into this value minus 5. Okay, so now here 2.094 whole cube. It is 9.181846 I have, so I am taking that 5 minus 2 into 2.094. Now it is 4.188 minus 5. Now what we have to do? We have to take the addition and subtraction of these. So now here what we get? 9.18185 minus 4.188 minus 5. So here it is. In your calci you will get it is nothing but minus 6.15 into 10 to the power of minus 03. The meaning of that one is 0.2 zeros. If you have power 3 then we have to take that simply 2 zeros. Now 615. Again it is nothing but of course negative we have. So negative means what we can say? F of x4 is negative. Therefore the root lies between. So in this interval what is the negative? 2.06 now. So now here we have to take this value 2.094 comma 2.125. Okay, and now here we have to calculate the value of the x5, right? So here x5, how we have to calculate? Simply take the addition of the interval values. So now here what we get? x5 equal to 2.094 plus 2.125 divided by 2. So now here 2.094 plus 2.125. So divided by 2 again, we have the 2.1095. This is nothing but the value of the x5. Now we have to observe that the value of the x4. What is the value of the x4? 2.09. Actually 09 means 1. So here it is nothing but 2.10. Both are somewhat near value but not exact. So that's why again you have to, of course if you want you can stop, but here I am going to calculate at least until we will get that the 1 or 2 digits will same after the point. Okay. Now again I am going for the next iteration. 6. Now f of x5 2.1095 whole cube minus 2 into 2.1095 minus 5. Now whole cube 9.38725 I have, so I am taking that 73, and next 2 into 2.1095, that is 4.219 minus 5. So now here what we have to do? Addition and subtraction. 9.3873. Okay, so then next minus 4.219 minus 5. This is nothing but 0.1683. Again it is a positive. So f of x5 is positive. Therefore the root lies between So here the interval is nothing but 2.094. This is nothing but the negative sign. Right now here we have positive. That means 2.094 will be same comma 2.1095 is the new value. Okay, so next again what we have to do, we have to calculate the next value, that is x6. Okay, and if we get the x6 value is also similar to x5, then we can stop the procedure, otherwise we have to proceed. So now here x6 equal to 2.094 plus 2.1095 by 2. Now it is 2.094 plus 2.1095 divided by 2. Now see here, 2.10175. Therefore x6 equal to 2.10175. So if you observe this x5 and x6, 2 is same, 0.1010 is same. So after the point, 2 digits are similar. I mean same, not similar, same, right? And after that we have 95 and here we have 175. And for this x6 we have the root that is nothing but 2.10. Therefore what you can say, I mean here you can stop the procedure, but now here what I am doing is I am going to calculate the next iteration also, because by that we will get some clarity about the answer. If we get again the same root, then yes, we can stop the procedure. Otherwise if we get some another value, then again we have to continue. Okay, now iteration number, of course with this also we can stop, but I am thinking about the third digit, because here we have 9 and here we have 1, somewhat difference, right? So now here f of x6 equal to 10175 whole cube minus 2 into 2.10175 minus 5. Now whole cube 9.28417. So 17 means I am taking that it is nothing but 2, and minus 2 into 2.10175. Now it is 4.2035 minus 5. Now finally what we get here, 9.2842 minus 4.2035 minus 5. Now it is 0.0807, which is a positive. Therefore f of x6 is positive. What we have to do now? Therefore the root lies between. So it is a positive and it is also positive, right? So that's why here what we have to do? Simply we have to take that 2.094 comma 2.10175. Now we have to calculate x7, that is 2.094 plus 2.10175 by 2. Then what we get, 2.094 plus 2.10175 divided by 2. It is 2.097875. So therefore x7 is equal to 2.0978. So if you observe this x6 and x7, of course here for x5 we have that the two values are similar, and here also 2.09. So 09 means actually here what we are getting, 2.10. 10 means can I take approximately 2.1? Yes. And here 2.1. And coming to here 2.09. So 09. So if we have here 9, then we can take that it is nothing but 2.1. So now therefore what we have to write? Therefore the required root for the given equation, for the given function value is nothing but 2.1. Approximately here you can take this one, otherwise directly you can write that 2.1. So now here what is the answer? The root of the given function is nothing but 2.1. So now you can substitute this 2.1 in a, obviously here we are getting that zeros only. Again no need to check. Okay, so this is nothing but the application, and here how many iterations we did? Simply up to 6 iterations is enough, but here for this one I am getting the another value, na? That's why here with this you can stop. Okay, so if you will get the similar value, then you can. So why I discuss this one? Because already I said we have to observe the next value also, and here what we are getting the same thing 2.1, but we are getting that it is 2.09, approximate value is 2.1. So you have to observe this one. So for each and every problem in this bisection method, every time you have to observe the value with the previous value. If you will get both are somewhat similar, okay, then you can stop the procedure and you can say that the lost value is nothing but the required root for the given function. So this is nothing but the bisection method, and yesterday we discussed one application and today we discussed another application. So while you are writing, be careful, and while you are taking the calculation part, then also you have to concentrate on that one, because if you will press minus instead of plus, then simply the entire problem will be wrong. Okay, so and it is enough to write up to here. Okay, now this is nothing but today's class. In the next class we will discuss some more applications related to this one, and we will start the next methods also. Okay, so thank you everyone, have a nice day.